Hi everyone, here are the worked solutions for the questions I had chosen for similar lengths. So question 1, we have each diagram below shows a pair of similar shapes or objects, and for each question we are being asked to first of all state the scale factor and then calculate the length of the side that's marked X. So for the first one here, we have two salt shakers and we have a missing side X on the larger of the two. Okay, so we would be working out our enlargement scale factor here. The pair of sides that match would be the 6 and the 4. Okay, that's corresponding sides on each one. So for enlargement scale factor, it's the big side over the small side. So we would be doing 6 over 4, which simplifies down to 3 over 2. So then to find the side X, we would be doing 3 over 2 times the side that matches the side that's missing. So that would be the 9 in this case. So 3 divided by 2 times 9 would be 13.5, and this one's in centimetres. Okay, for question B, we have two pictures of drills and the side that is missing is on the smaller of the two. So we will be doing reduction scale factor here. So that is small over big. So the pair of sides that match on these diagrams would be the 21 and the 14. So in our fraction here, we would have 14 over 21, which simplifies down. They both divide by 7 to 2 over 3. So to find side X, we would be doing 2 over 3 times the side that matches the missing side, so times the 30. So 2/3 of 30. So 30 divided by 3 times 2, so that's 20. And that one's also in centimetres. Okay, same idea for C and for D. So for question C, it's two lampshades and the missing side is on the bigger of the two. So it will be enlargement scale factor we need to use here. So our pair of corresponding sides would be the 50 and the 20. That's a pair that a side that matches on each picture. So enlargement scale factor is big over small. So it'll be 50 over 20, which simplifies down to 5 over 2. So to find side X, it'll be 5 over 2 times the side that corresponds with X, which would be the 18. Okay, so 5 divided by 2 times 18 would give you 45, and this one's in centimetres. And the last one here for D, we have a missing side on the smaller of the two pictures of hammers here. So it's going to be reduction scale factor. Our pair of sides that go together would be the 96 and the 160. So for reduction scale factor, it's the small side over the big side. So it would be 96 over 160, which simplifies down to 3 over 5. Okay, and then to find side X, it's our scale factor times the side that matches the missing side, so it'd be the 280 here. So 3 divided by 5 times 280, which gives you 168 millimetres. Okay, question 2 was the next one I had set. So here we have our similar triangles, and if we remember here from your notes, the X shape gives you the pairs of sides that kind of go together. So for the first one here, we have our matching pair of sides would be the 20 and the 36, okay, because it's with the X shape. So that tells me that the top triangle is the big one and the smaller triangle is the one on the bottom here. So our side that is missing is side X, which is on that smaller triangle. So for this one, we're going to be using reduction scale factor. So it's the small side over the big side, so 20 over 36. Okay, and that simplifies down to 5 over 9. So to find side X, it will be 5 over 9 times the side that corresponds with our missing side, so the 54. So 5 divided by 9 times 54 gives you 30, and this question's in millimetres. Okay, Question B, again, we have the X shape, and we can see we have actually the two vertical sides would be our pair. So 24 and 30. So that means that that one there is the big side on the right. The smaller triangle is the one on the left. So our missing side is on the bigger triangle. So it's going to be enlargement scale factor we'll use here. So it'll be 30 over 24, which simplifies down to 5 over 4. So the missing side X, we will do 5 over 4 times, and the side that corresponds with that X is the 26. So 5 divided by 4 times 26 gives you 32.5. And this one's in centimetres this time. Okay, question 4. Now this is one where quite a few people were asking me for help with, especially the first one here. So let's call this one 4A and 4B. So for question 4A, we have our similar triangles, but we have one on top of the other. So you remember from the example in the notes that I was saying it was the best kind of strategy to try and separate out your triangles. Okay, so if we think of, we have our sort of smaller triangle, and then we have our larger triangle sort of separated out. On the smaller triangle, we have that side X, and we have the 24. On the bigger triangle, we have 18, and then that big long side there, all the way up from either end, would be 24 plus 8, so 32 up that big long side there. Okay, so the side that is missing is here on our smaller triangle, so we're going to do reduction scale factor. And our pair of sides that match corresponding in each triangle is the 24 and the 32. So for reduction scale factor, it's the smaller number on top, so 24 divided by 32. Okay, when you simplify that down, you get 3 over 4. So side X will be 3 over 4 times the side that matches with that, so times that 18. So that's going to give us an answer there of 13.5, and that question's in centimetres. Okay, for B, we have a similar idea. We have two triangles, kind of one on top of the other. So if we separate out our triangles, we have our smaller and our larger. So the smaller one, we have X and we have 16. On the larger one, we have 36 down the side and 40 at the bottom. So the side that's missing is on our smaller triangle. So it's going to be reduction scale factor again. And our pair of sides that correspond together would be the 16 and the 40. So we're going to do 16 over 40, which simplifies down to 2 over 5. So to find our missing side X, we're doing 2 over 5 times the side that corresponds with X, which would be the 36. So that's going to give us 14.4, and that question's in millimetres. All right, next question is question 5. Again, I had quite a few people asking me about this one. So here again, we have our similar triangles, one on top of the other. So we're told here that this is an aluminium pipe frame, and we have two parallel lines. So QS and PT are parallel. So that's how we know that this is similar triangles, okay? We then have the various measurements written out in the question, and they're also put onto the diagram. Okay, so we have our 48, our 24 and our 32, and they're all on the picture. And we're asked for the length of the side that's ST. So that is just this little bit here in red. Okay, so just that wee side there. So we need to, first of all, separate out our triangles. Okay, so we have our smaller triangle, and then we have our larger triangle. Okay, so on the smaller one we have 24 at the bottom, and on the larger on the smaller one we actually have 48 there as well. On the larger one we have 32 along the bottom, and we don't actually have the big long side, but we'd actually asked for just a piece of this, so we're sort of asked for this piece here. So we have to think about what our strategy would be, okay? We know that we have 48 from R to S, and we're being asked for the length of S to T. So what we need to find out first of all is the whole length of that side, okay? And then to find S to T, we would just subtract 48 from the whole side. So what we actually need to do first of all is find that side there. So I'm going to call that X. So our missing side is on our larger triangle. And our pair of sides that match is the 32 and the 24. So what we need to do, first of all, is our scale factor. So our missing side is on the larger of the two. So it's enlargement scale factor. So we're going to do 32 over 24, which simplifies down to 4 over 3. So then to find side x, we're doing 4 over 3 times the side that matches, so 48. So that is actually going to give us 64 centimetres. So 64 centimetres is the whole length from R all the way down to T. So to find the length of just S to T, all we need to do is 64 subtract 48, and that's going to leave us the little bit in red, the S to T part. So that is a length of 16 centimetres. Okay, the last question, and this one in particular was one that a lot of people were getting in touch with me and asking about, so I thought that's why I thought it would be best to do a video to explain. So this one here, it really is a sort of problem solving style question. It's much harder than the ones that we've completed so far. So here we have a diagram of a ladder that's laid against two walls that are shown. The higher wall is 1.6 metres tall and the smaller one is 0.7 metres tall. And the distance between the two walls is 0.9 metres. And we're asked to find the distance between the foot of the ladder and the lower wall. So if we mark that on our picture, that's the wee bit there we're being asked for in red that I've drawn there. The foot of the ladder to the lower wall. So that's what we're being asked for there. So let's call that X to start with. So if we go ahead and separate out our triangles like I was explaining to do before, we have our smaller triangle and we have our larger triangle. So on the small one we have X along the bottom and 0.7 up the side. The bottom one, we don't actually have a measurement for this long side, but if we think of the whole thing, we could call this X plus 0.9 because that would be those two pieces added together for the full length. And then up the side of this one we have 1.6. So let's now think about how we could go ahead and solve this, okay? Now, normally what we would need to do is we would do our scale factor, which we could do because we're looking for the side X, so we could go ahead and do 0.7 over 1.6. But we would need to know the bigger side that corresponds with X, so that we would multiply our scale factor by that larger side. Because we don't have a measurement for that larger side, we don't have a measurement for this. What we can do instead is we can actually compare these sides as two fractions because the sides of these triangles will be proportional to each other. Okay, so what we can do is we can set these up as fractions. So we know that if we compare the big triangle to the small triangle, we have 1.6 over 0.7. Those two sides, the two vertical sides, should be the same scale factor as if we compared the two horizontal sides. So if we take the two horizontal sides and compare those in a similar way, we should end up with the same two fractions, okay? The same scale factor would be in each pair of fractions. So 1.6 over 0.7 would be the enlargement scale factor from the small triangle to the big triangle, which would be the same fraction as if we took the big side and compared that to the smaller side along the horizontal edge. Okay, and this would actually work either way around. So if you wanted to do 0.7 over 1.6 equals and then do X over X plus 0.9, you would get the same answer. It doesn't matter. Okay, you're just comparing the sides that match as fractions. From here, now what we can do is just cross multiply and solve. Okay, so if we solve this, so cross multiply, so kind of like the working that we do when we're doing arcs and sectors, okay, similar to working to that. So 1.6 times X, so 1.6x equals, and then 0.7 times X plus 0.9. Now that's just an equation to solve, so 1.6x equals 0.7x plus 0.63. If you multiply that bracket out, we would then take away 0.7x from both sides. So that's going to leave us with 0.9x equals 0.63, and then divide both sides by 0.9. So we're going to get x equals 0.7, and this question was all in metres. Okay, so like I said, that method works if we don't have the matching side to the unknown one so that we can multiply that by our scale factor. So if you don't have the side that you need to multiply by, you can use this method of setting up your pairs of values as two fractions and then cross multiply. Okay, so hopefully that is a little bit more clear now and helpful to those of you that were not so sure of this question 6.